Lesson 5-4. Solve trigonometric equations. The main goal is to isolate a trigonometric expression. So you can do this by using identities to simplify. Or maybe you could factor, or various other things that we've done in the last couple lessons. Now we have this issue with number solutions. Consider sine of x equals 0. Well, here's a graph. Where does sine of x equal 0? Well, there, and there, and there, and there, and there, and it keeps going. So it looks like it's 0 and pi and 2 pi and negative pi and negative 2 pi, and it goes forever. So there's infinitely many solutions, so you have to describe these solutions. And it looks like they're multiples of pi. So it'd be 0, starting here at 0, plus a pi, because the distance between each of these is pi. So 0 plus some multiple of pi, which simplifies to n pi, where n is a multiple, or is any whole number, or any integer. So let's solve this equation. So first of all, probably what I would do is get the signs together, like terms. So I'd have negative square root of 2 equals negative sine of x, 2x. Then I divide by the negative 2 to get the sine of x by itself. So we have to look and think, oh wait, when does sine of x equal square root of 2 over 2? So that might be helpful to have a unit circle. And sine is y on our unit circle, so we want the y to be square root of 2 over 2. Positive square root of 2 over 2. So it's both of those places, and the angles are actually pi over 4 and 3 pi over 4. All right? So x is going to be pi over 4 and 3 pi over 4. But we could go around the circle again and have that answer. And then we could go around again. So all the coterminal angles are also solutions. So we could add 2 pi, some multiple of 2 pi to those. And that would give you all the solutions where n is in any integer. Let's try another one. Well, sine is just here once, so maybe we'll try to get the sine by itself. So we could add 3. Divide by the 4. And since it's sine squared, square root. Don't forget the plus and minus. So it'll be the square root of 3 over 2. All right, so where on our unit circle does sine, again, sine was y, so where's the y square root of 3 over 2? Well, there at pi over 3. There at 2 pi over 3, so that's the positive square root of 3 over 2. Or here at 4 pi over 3, and there at 5 pi over 3. So we could say x is pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. But again, all the coterminal angles also count. So you could say plus 2 pi n. But notice, pi over 3 and 4 pi over 3 are directly opposite each other on the circle. So if I take pi over 3 and just add pi, I'm at 4 pi over 3. And if I add pi, I'm back to pi over 3. So I could just say pi over 3 plus pi n, and then I wouldn't have to put the 4 pi over 3, because when n is 1, that is 4 pi over 3. The same thing is true here between the 2 pi over 3 and the 5 pi over 3. Because they're directly opposite each other on the circle, if I just add pi, that gets me to the next one. So if I add pi n, that would work. So our answer would be pi over 3 plus pi n, and 2 pi over 3 plus pi n. Let's try another one. This one has sine on both sides, so maybe if we got them on the same side, and made it equal to 0, and then looking, say, maybe we could factor, because there's a sine in both, so let's factor out a sine x. If I do that, I'll be left with a sine x and minus 2. Then you take each factor equal to 0 and solve each of those. So the first one, when does sine of x equal 0? Well, the sine is the y, so it's here and there. So that's where it equals 0, so that appears to be 0. Or pi. Or notice, if I go 0 plus pi n, or simply pi n, all the multiples of pi. So n could be 0, that would go 0. N could be 1, that would give me pi. N could be 2, it would give me 2 pi. Our other one here, sine of x equals 2. When does sine of x equals 2? Well, on the unit circle, the radius is 1, not 2. So this is never. No solution there. So our answers are just multiples of pi. All right, looking at this one, I see we have secants and tangents. So maybe we'd have to use an identity to get them to be the same thing. So I know secant squared is tangent squared plus 1. Remember, that was a Pythagorean identity. All right, so then if we simplify, so that would be 3 tangent squared plus 3 if we distribute. Let's collect like terms. 3 tangent squared and minus 2 tangent squared would be 1 tangent squared. And 3 and negative 4 is minus 1. And now we just have tangents, so let's move the 1 to the other side, so we add 1. And then square root. When we square root, don't forget the plus and minus. So where does tangent equal 1? Well, tangent is y over x, so I want the y and the x to be the same. So that's here at pi over 4. And here at 5 pi over 4, that's where it equals positive 1. Here's 3 pi over 4 where it's negative, and 7 pi over 4 where it's also negative. All right. I'd like you to notice something though. So we could say it's pi over 4 plus 2 pi n, 3 pi over 4 plus 2 pi n, 5 pi over 4 plus 2 pi n, and so on. Or maybe you can notice, oh, the pi over 4 and the 5 pi over 4 are directly opposite each other. So I can say it's pi over 4 plus pi n. But I want you to notice, these are perpendicular. So to get from one to the next, we just have to add 90 degrees, or pi over 2. So we could say x is simply pi over 4 plus some multiple of pi over 2. And that's special in this case because it just so happened to be that there's pi over 2 between each of the answers. All right, these instructions are slightly different. These, we just want all the answers between 0 and 2 pi. So you don't have to say plus pi n. They just want a list of all the answers. All right, in this one, notice we have both sine and cosine. Okay, so maybe we can make those the same. What could we do? I know a sine squared and a cosine squared. Well, why don't we just square both sides? If I square sine plus 1, that would be sine x plus 1 times sine x plus 1. So that would be sine squared x. That'd be sine x and sine x, and 1. Well, now we have both sine and cosine, but I know that sine squared plus cosine squared equals 1. Therefore, cosine squared would be 1 minus sine squared. So I can replace that cosine with 1 minus sine squared. Let's get everything on the same side. So if I add sine squared to both sides, I'll have 2 sine squared. And if I subtract 1 from both sides, they'll go away. And now I have just sine. So now I can solve this. Since there's a sine in both parts, I could factor. I could factor out a 2 sine of x, leaving sine of x and a 1. Take each of those equal to 0. And so I get sine of x equals 0, and I get sine of x equals negative 1. Let's start with the 0. Where does sine of x equal 0? Well, it's the y value, so it's there and there. Okay. So that would be 0 and pi. And remember, we're not doing plus pi n or anything because I just want a list of all the answers between 0 and 2 pi. Our other choice, when does sine of x equal negative 1? Well, that's the y value, so that's down there. So that would be 3 pi over 2. And those are all your answers. Let's try another one. So it looks pretty straightforward. A lot of you will want to divide by the 2, but the 2 is inside of the sign, so you cannot divide by 2. You have to get rid of the sign first. So since it's already solved for the sign, let's just figure out when does sine equal 3 pi over 2. That's the y, so it'd be here at pi over 3, and here at 2 pi over 3. Those are the two places where the y is 3 pi over 2. But notice this is 2x. That means we're going to have to go around the circle twice. So if I go around again, if I add 2 pi to that, I'll have those. And if I go around again, so that's pi over 3, that's 2 pi. 2 pi plus pi over 3 would be 7 pi over 3. And 2 pi over 3 plus 2 pi is going to be 8 pi over 3. Now, why did I have to do that? Because my angle is 2x. When I go and divide by 2 to get x by itself, I'm going to cut all these in half. So if I cut it in half, if I start with 2 complete circles, when I cut it in half, I have 1 complete circle, which is the interval I'm trying to get. So pi over 3 over 2 is pi over 6. 2 pi over 3 over 2 is pi over 3. 7 pi over 3 over 2 would be 7 pi over 6. And 8 pi over 3 divided by 2 would be 4 pi over 3. You would not have gotten these last 2 answers if you had not gone around the circle twice. If it was a 3x, you would have to go around the circle 3 times. If it was a 4x, you would have to go around it 4 times. Or if you'd like, you could have said 2x is pi over 3 plus 2 pi n. Or 2 pi over 3 plus 2 pi n. And then when you divided by the 2, you'd get pi over 6 plus pi n, or pi over 3 plus pi n. Well, what's pi over 6 plus pi? If I let n be 1, that would make it 7 pi over 6. And for the second one, if I let n be 1, pi over 3 plus pi would be 4 pi over 3. And you see, oh, there's those answers. Our last one, let's solve this. This one appears to be quadratic. So let's get it all on the same side. So subtract the 6 from both sides. And factor. So what times what makes tangent squared? 4 tangent squared. So let's try 2 tangent and 2 tangent. And to get 6, maybe a negative 3 or a positive 3 and a negative 2. And if we check, that's negative 4 and that's 6, so that's only 2. That did not work. We'll have to try something else. How about a 4 and a 1? So that'd be negative 8 plus 3 is negative 5. Oh, hey, that's just about it. So then I need to change my signs so that it's negative and positive. And then I could take each factor equal to 0. Solve each of those. For the first one, we would have 4 tangent of x equals 3. So tangent of x equals 3/4. Is that on the unit circle? Nope. So if we want the exact answer, we'd have to just leave it as the inverse tangent of 3/4. Same way with tangent of x equals 2. Tangent on the unit circle, the special angles, tangent doesn't equal 2. So we would just have to leave it as the inverse tangent of 2. And that would be the exact answers. Of course, you could put it in your calculator and get what the numbers are. I missed something though. I'm supposed to have all the answers. This one does not say only between 0 and 2 pi. So, do you remember what is the period of tangent? The period of tangent is pi. Sine and cosine are 2 pi, but tangent was just pi. So instead of adding 2 pi in, we're just going to add pi in because tangent repeats every pi. And that's all there is for today. We'll keep coming back to this in the next bunch of lessons. So if you'll get plenty of practice.